How does a byte data type range is calculated in Java? A byte has 8 bits. 8 bits can store 2 raised to the power of 8 values, i.e. 256 values. 1 bit can store 2 values. 2 bits can store 4 values, and so on. Since 8 bits can store 256 values, and we are talking about storing numbers, we need to store negative numbers too. Out of the 8 bits, the leftmost bit is assigned to store the sign, 0 for positive number and 1 for negative number. Sign bit, 1 for negative number. Sign bit, 0 for positive number. Rest 7 bits are used to represent the numbers. Now, let's see how positive numbers are stored. For a positive number like 5, its 8-bit binary form is 00000101. The first slash leftmost bit is 0, indicating it's positive. The remaining 7 bits give the value. Now pause the video and go through these examples to understand how binary numbers represent decimal numbers. Next, let us learn how negative numbers are stored in computer's memory. It uses 2's complement. Step 1. Start with the positive version. For example, take the number 1. Its binary in 8 bits is 00000001. Step 2. Invert the bits. Change every 0 to 1 and every 1 to 0. Step 3. Add binary 1 to the inverted number. Result: 11111111 represents -1 in 2's complement. Example with -128. The binary representation for -128 in 2's complement is 10 million. Try it on your own. Why? When you try to invert and add 1 for 128, you realize that this is the lowest possible number representable in 8 bits. Now you can pause the video to understand how the 2's complement works for these few negative numbers. Example 1.
Example 2.
Explaining the range, -128 to 127. Positive range. With 7 bits for the magnitude, you can represent values from 0 to 127. Negative range. Because of 2's complement, the negative side goes from -1 down to -128. Notice that there is one extra negative number because 0 is included in the positives.